Hey Chem Kids, Miss Venable here. Today bringing you some lab data for properties of ionic and covalent bonding. So let's get started. First we're going to observe some of the physical properties. So take a look at this calcium chloride. Notice that it is white. It's solid, not liquid or gas, and it appears to be crystalline. It's kind of hard, brittle, like a crystal should be. And the next one we have is citric acid. It almost looks like table salt. Again, white, solid, crystalline. And then we have wax. Okay, this has a little bit different texture. It is white, it is solid, but it feels not crystalline. So no crystalline structure on that, not crystalline. And then next we have sodium chloride, which is just good old table salt. Again, it's white, solid, and crystalline. And then the last substance we have is sucrose. Sucrose is just common sugar. So again, white, solid, and crystalline. So you're going to record those physical observations in your data sheet. And next we are going to heat it and test the melting. Next we're going to do the relative melting point determination. So with my 5 samples, I'm just going to put them on the hot plate here and turn that on. And I'm going to watch and see which one melts first. So whichever one melts first, I'm going to label as number 1. The second one I'll label as number 2, the third one number 3. And if it doesn't melt, I'll just put an N for does not melt. And I can see that my hot plate's been on just a couple of minutes, and one of these is already melting. So that is right here. This is already melted. That is the wax. So next to my wax for relative melting point determination, I'm going to label that as number 1. It melted first. All right, so our wax is completely melted, and I see here that my sucrose, my sugar, is starting to melt, and it actually is turning into caramel. So this brown stuff here, when sugar melts, it makes caramel. So we're going to label our sucrose as number 2. All right, the next one to melt is my citric acid, and I can see here that my sucrose is pretty caramelized, and then here's my citric acid completely melted. And the last two, the calcium chloride and the sodium chloride, they have not melted at all. So I'm going to put an N for both of those.
Like squirts and then start stirring?
Mm-hmm. Okay, so next we're going to do the solubility in water test, and my wonderful assistant Casey is going to squirt some water into each well. So the first well is the calcium chloride. Go ahead, Casey. And she's going to squirt some water in there and work on dissolving that. Go ahead and squirt water in all of them there, Casey. So this one's going to be the citric acid, and the wax is getting some water, and that's the sodium chloride, and that is the sucrose getting some water. So Casey's going to work on stirring these and see if they dissolve. We're testing to see if they are soluble. If they're soluble, they do dissolve. And we will come back to check on them after she has stirred. All right, so she has stirred, and I see here that all of these dissolved except for the wax. So all of these were soluble except for the wax. Everything dissolved. The wax did not dissolve. So in our data table here, we're going to record the results for solubility in water. Next, we're going to test conductivity. If they are ionic and they are dissolved in water, then they should be very good conductors of electricity. And we're going to test this because we have a light bulb. So if the light bulb lights up very bright, then that tells me the compound is ionic. So this light bulb is connected to 2 electrodes, and we have dissolved our substances in water, and we're going to put that into our electrodes. So lights, please. And calcium chloride is very conductive, I can see, because the light bulb is very bright. The next solution we're going to test is citric acid. But first we need to rinse off our electrodes so that we don't cross-contaminate our liquids. Okay, here comes the citric acid. And that one is not as bright. Citric acid is a dim. Thank you. And let's rinse again. And the next one we're going to test is the wax. And I can see that it did not light at all. And we're going to rinse so we don't cross-contaminate. All right, the next one we're going to test is the NaCl, sodium chloride. Ooh, that is very bright. Very, very bright indeed for the NaCl. And we will rinse. Thank you. And the last one we're going to test is the sucrose. And that does not light at all, so no light there. And then we will rinse one last time. And that concludes the test for conductivity. Please record your results in your data table. So in this experiment, we were really testing 3 different properties. First, we tested the melting point. And what we know about ionic substances is that it takes a lot of heat to melt them. Their melting point is very, very high. So look for ones that did not melt on our hot plate to be ionic. The second thing we tested was solubility. What we know about ionic salts is that most of them are soluble. Not all, but most. So look for the ones that may or may not have dissolved. Now that doesn't rule it out because a lot of covalent molecules will also dissolve in water. Last but not least, we tested conductivity. And we know that ionic substances are good conductors of electricity if they are aqueous or molten. Now, when they're in their solid state, their crystalline lattice, they do not conduct electricity. But because when you put them in water, they dissolve, the metal ions dissociate, and you have these metal ions running around. Remember, metals love to give away valence electrons. So you've got these valence electrons floating around in the water, and that's what conducts the electricity for you. So this has been Miss Venable bringing you the properties of ionic substances and covalent substances lab. Thanks so much for joining me.